Everybody, coming at you today with a quick video talking about speed and velocity, the similarities and differences between the two, and how you could find the velocity and the speed of an object if you know the right information. So velocity is displacement over time and speed is distance over time. We're going to look at this motion, and this is the motion of somebody who moves 8 meters in 4 seconds, 8 more meters in the same direction in the next 2 seconds. And then they turn around and come back 8 meters in 6 seconds. And we're going to find the speed and the velocity, and I'll show you how to do that. And I'll show you that you could get a different number depending on what you're looking for. Right? And so stay tuned to see what I'm talking about. So first of all, distance and displacement are not exactly the same thing. I have another video where you can learn more about that, but assuming you already know that. Velocity is displacement divided by the amount of time that goes by. Speed is the distance divided by the amount of time that goes by. A big difference is velocity really measures how far something is getting away from something else, whereas speed is just how fast is something moving, period, right? Regardless of what direction it's going. So let's look at this motion that I just showed you, and we're going to graph the position versus time. So imagine that the starting point is 0, and that's where we put the starting point of the graph. In the first 4 seconds, it moves 8 meters forward. So that's why it goes up 8 meters on the position graph, and it goes over 4 seconds on the time part. Then for the next 2 seconds, it goes up another 8 meters, from 8 meters to 16, and that takes 2 seconds. So we're already at 4 seconds, so obviously it takes till 6 seconds. And you see that gives us a steeper line. Then the next part on the position graph is the line goes down because the person is getting closer to where they started, closer to the 0 mark. And that takes 6 seconds. So it goes from 16 down to 8, and the time goes from 6 to 12. So if you ask for velocity, there's 2 things you could be thinking about. You could be thinking of instantaneous velocity, which is how fast it's going at a certain moment, or average velocity, which is how fast is it going overall? How fast is the position changing overall? So instantaneous velocity is found by looking at the slope of the position time graph. Right? And so if you look at this again, for this first period of time, you see there's one slope. For the next period of time here, there's another. And then for the last period of time, there's another slope. Each of those slopes can be found by doing rise over run mathematically, which is really just how far did the position change divided by the time, which is actually the equation for velocity. So 8 meters divided by 4 seconds is 2, and this line has a slope of 2. Then the next motion is 8 meters in 2 seconds, which is 8 divided by 2. And so that line has a slope of 4. Then it goes back down. And so the position changes by -8 in 6 seconds. So you divide -8 by 6, and you get a slope of -1.33. Right? So those are all instantaneous velocities. So if I asked you what's the velocity at, say, 5 seconds, okay, you say, okay, that's in between 4 and 6. So that's part of this slope, which is 4 meters per second. And so instantaneous velocity tells you how fast it was going at any given time. Now, average velocity is where you just take how far has the position changed, the displacement, and divide it by how much time has gone by. Right? And so when we do that, displacement divided by time, displacement is just 8. Right? And there's a video about how to find displacement on a position graph you can check out. But displacement is 8 because it's 8 away from where it started. And the time is 12 seconds. So you divide those, you get 0.67 meters per second. And so that's your average velocity. Notice it's never actually going 0.67. It's always going faster than 0.67. But because some of the time is moving away, some of the time is moving back, those kind of cancel out. And so you get a smaller velocity. Essentially what you did is you imagine if you only look at the end result and graph a line from 0 out to the end result, you're looking at the slope of that line. Okay, and you see the slope of that line is not as steep as the other parts, but it's an average. Now let's look at speed. So speed can be calculated from a distance versus time graph. So the difference between this graph and the one before is the position graph is showing us where the object was at any time. The speed graph, the distance graph where we find speed, is showing us how far it had gone at any given time. And so you find the slope of this, you'll find the instantaneous speed. To find the average speed, you'll have to use the equation. So looking at this, similar to the velocity, we just find the slope of the distance graph. And that would be 8/4 for the first motion, because they traveled 8 meters in 4 seconds. Then 8 divided by 2 for the second motion. And you see that gives us 4, and the slope of this line is 4. And then 8 divided by 6, this time it's going to be a positive 1.33 because it's moving 1.33 meters per second. And that means its distance is increasing by that much every second. Whereas with velocity, it was getting closer to 0, so we made it negative. Now that gives us the instantaneous speeds. So again, you could if you were asked a question like what was the speed at 9 seconds, you would just come over to the graph. Speed is somewhere between 8 and 10. 9 is somewhere between 8 and 10. And so it would fall on this line. The slope of that line is 1.33. So the answer would be at 9 seconds, it was moving 1.33 meters per second. Now you might want to find the average speed. And average speed is distance divided by time. And so you can see that the distance that it got to was 24. Right? Because the graph ends up here at 24. It's taken 12 seconds, so 12 goes on the bottom. And you divide that, you get a speed of 2 meters per second. And if you're looking at the graph, it was going 2 meters per second for a while, then it was going faster, then it was going slower. What we've done with this equation, you wouldn't want to actually average these together like the way you add numbers together and divide them, because they're for different amounts of time, so you can't find it that simply. But if you find the final distance and divide by time, you can find the average speed that way. And so essentially what you did is you can imagine if you just assumed it was constant motion and did a straight slope till the end and found the slope of that line, that dotted line, it would be 2. Okay, so you're seeing it's going at an average speed here. Here it's going faster. Here it's going slower, but in the end it averages to be 2 meters per second. All right, hopefully this video helped. We have some other videos to help you if you need more help on this topic. Hope to see you all in another video.